after we're done with training today, what I'll do is I'll go ahead and place this training video that we're doing today out on our YouTube training channel. Now, Tony, if you haven't got that, or if you guys don't have the link yet, Tony will be sure and get that to you. And so it'll be out on the YouTube training channel. And the date, today's date is 05/29/2024. And so the name of our training will be Cape Coral HMH Training Overview, with today's date 05/29/2024. So you can go out there and review this as much as you like with that training link. And we've got about 60 videos out there. So by all means, we'll be adding this to the archive. And please go out and take a look at it as much as you like. At this time, I'm going to go ahead and secure my camera because I seem to stream a little bit better with the PowerPoint presentations when I shut my camera off. So let me go ahead and shut that off real quick. And then we're going to get right into our program. And Tony, as usual, I'm going to let you kind of be the scribe to make sure that, you know, it's all looking real good on that end and so on. So let me go ahead and share my screen at this time. And we'll start getting squared away here. Okay. So Tony, at this point, can you see the screen okay?
Looks good, Joe.
That sounds good. Thank you for that.
So
okay,
the recording isn't going to be of my guys, right, in the video. The recording is going to be what we see on the screen.
That is correct.
Okay. That
is correct. And the sometimes based on how the technology is on your end, there may be a blurb, or there may be some stuff on there. For instance, when we're talking and stuff like that, you know, your camera will be on. But right now, the only thing that you should be seeing should be my screen. Is that correct, Tony? Can you guys see the screen okay?
Yes, yeah. It looks good, Joe.
Okay. So, fellas, a couple things we want to talk about on the HMH7, where we always like to kind of kick this off, is the fact that you've got a 2-fan models and you've got a single fan model. So as you take a look at the photo on the right-hand side, the single fan models are going to be the 2 and 3 ton models. They'll have a single fan, and then the 4 and the 5 ton model will have a dual fan. So that's a good way to look at it. You'll know immediately by looking at it, whether it's a 2 and 3 ton, the single fan model, or if it's a 4 or 5 ton with the 2 fan model. In addition, even though these guys kind of look like mini splits, they are absolutely not a mini split. I want to make sure that everybody understands that. You're going to pipe these up like you would any other heat pump. You're going to run a suction line. You're going to insulate it just like you normally would. You're going to go ahead and utilize a liquid line just like you normally would. And then it's going to be simple 24-volt wiring. So you're going to have your favorite heat pump thermostat on the wall, and you're going to bring wires outside, 24-volt wires. You're going to hook it up just like you would a conventional heat pump. As a matter of fact, one of the neat things about wiring this thing, and we'll get into this in a little bit, we'll get into it more, I should say, is the fact it's very, very simple 24-volt wiring, and you actually wire it like a single-stage unit. It's the weirdest thing. You just have a Y signal going outside, and then there's a lot of intelligence on the board outside. These units will actually modulate, fellas, between 35 and 100% capacity. So the outdoor unit's got a lot of intelligence. It's got some sensors out there. It's got an outdoor air sensor, has a discharge line sensor, a liquid line sensor, a suction line sensor for temperature, as well as some pressure transducers out there. So this unit's constantly looking at the refrigeration cycle and these critical temperatures to make intelligent decisions on what point to be for capacitor, what point of modulation. So the outdoor unit modulates from 35 to 100% capacity. And on the indoor unit, we're going to command 65% or 100% airflow, which we'll get into more a little bit later. In addition, please remember the actual unit itself. To service the unit, you're going to have this little adapter. It goes from 5/16 flare to a 1/4 inch for your service hoses. So there's a picture of that adapter right there in the lower left-hand corner of the screen. It's just a little adapter. There's several companies that make these, you know, JB and Robinair, just to name a couple. But please remember, you're going to have this adapter to get on to the service valve for your service hoses. Okay, let me get over here real quick. All right, the next thing we'd like to just kind of touch on a little bit. I know that down in your part of the woods, you guys aren't going to have any really cold weather down there, but these things really have a very, very nice range in the cooling mode of operation. They go all the way down a minimum of outdoor coil temperature of 35 degrees for cooling. So you can actually cool down to 35 degrees outside. In the heating mode of operation, you go down to -5 Fahrenheit. And in the cooling mode of operation, the maximum outdoor temperature for a normal operation would be 122 degrees, up to 122 degrees outdoor temperature for cooling, and 75 degrees. I mean, I can't imagine anybody really wanting any heating at 75, but they're rated to actually be utilized for heating as high as 75 degrees outside. So you can, so I like to kind of pop that little chart right there to kind of show everybody there's just a tremendous capability with these heat pumps. Any questions or comments so far?
No, not yet. Once we get a little further into it, like my question now would be, how many wires do I have to have outside? Is this going to be a 5 or 6 wire for low voltage? But I feel like you're probably going to get into that.
We will, and thank you for that great comment. There's actually going to be 5 wires outside, but we'll get into it here shortly. We're going to be getting into some block wiring diagrams to where we're going to literally go wire for wire for wire for wire from the thermostat to the indoor unit to the outdoor unit. So we'll get to that in just another minute or so. So I guess with all that said, we're going to start discussing low voltage wiring at this time with the HMH7 and a JHVT air handler specifically. Guys, now please remember this is an extremely versatile unit. And I know you fellows probably don't have much furnace work down there or anything like that, but these things will hook up just perfectly fine with a furnace or with a JHET air handler or with our modular air handlers. Basically, this is one of the most versatile outdoor units we have. It's literally rated with everything in our inventory as far as indoor products, with the exception of what we call the JHVV, which is going to be strictly used for the 20 SEER product, you know, the real high-end product. So at this time, we're going to talk a little bit about hooking it up again to the JHVT air handler. We're going to study some low voltage block wiring diagrams and literally take it wire for wire for you. We're also going to be talking about that S1 circuit for reduced airflow that we're going to be doing on the air handler. In addition, we're going to talk a little bit about an alternate relay kit. Now, you do not, let me stress this, you do not have to have a relay kit with this unit. So with our other air handler products and our furnace products, we have a relay kit that you're going to utilize with this product. You do not have to have the relay kit with the JHVT air handler. However, we have found in some areas of the country, based on the quality of the power, that the alternate relay kit is an option as well. And we're going to talk about that as well, because I don't know what kind of power systems you guys have down there. And if you have kind of iffy power, we've found that utilizing the relay kit gives you a little more reliable system. In addition, we're going to talk about that heat pump thermostat. You're going to have to make sure that your heat pump thermostat, whichever one you select, put your favorite thermostat on the wall. But you're going to want to make sure that your heat pump thermostat has a BO selection for reversing valve operation, because this product is going to energize the reversing valve. Now, please write this down or put it in your back pocket. It's going to energize the reversing valve in the heating mode, not the cooling mode, the heating mode. So we're going to energize B for heating mode on our product. So with that said, let's go ahead and jump into some of those block wiring diagrams and dip switches and stuff like that. We're going to start getting into some of the finer details now, as far as the air handler and wiring it up and all that kind of stuff. But before we jump into block wiring diagrams, let's talk a little bit about the dip switch selection on the JHVT air handler. Now, when you open up your install guide, and we want to make sure you guys look at the install guide, it's going to give you a good explanation of how to set these dip switches up for various operations. One of the big ones that I want you to remember is you want to make sure and set your airflow settings up for the amount of airflow that you want on the indoor unit. One of the big ones, fellas, is the fact that you always want to set your airflow up and design your ductwork to have 400 CFM per ton of cooling capacity. So if I've got a 2-ton unit outside, I need to set these dip switches up for 800 CFM for my high cool airflow. If I have a 3-ton unit outside, I need to set them up for 1200 CFM and so on. So we always want to set up our airflow on our indoor unit for 400 CFM per ton of cooling capacity of the outdoor unit. Any questions or comments on that real quick?
No. Are these going to be available in half-ton options, or is it going to be strictly by the ton?
I love that great answer, or that great question. And the great answer is their whole tonnages, 2, 3, 4, and 5 on this product. And the reason being, if you think about it, they modulate between 35 and 100% capacity. So to kind of put this in perspective, that 2-ton unit's going to screw down to about a ton. And the 3-ton unit is going to screw down to about a 1.5 tons, and so on, all the way up to its full capacity. So there's such a tremendous operating window with capacity on these things that we don't have half tonnages. That was a great question. Good question. Okay, so you're going to notice on the control board itself, one of the ones we're going to kind of really drill into right now is, read the install guide, look all about it as far as your dip switch selections and stuff like that for airflow configuration, as far as your heating airflow, your cooling airflow, and so on. But one of the big ones I want everybody to kind of drill in right now as we talk about this is our AC/heat pump switch. Now this is important if you want, now I want you guys to catch this. If you want the air handler to be utilized as the S1, our airflow reduction circuit, you don't have to have the relay kit. But there's a couple steps you have to take to tell the indoor unit that you're not going to use the relay kit. So we're going to be talking about that. We're going to talk about utilizing the relay kit as an alternate. We'll walk through that as well. But if you're not going to use the relay kit, it's very, very important that you take this heat pump AC switch. It has to be in the HP or the heat pump position. Now, with S1, which is going to be our airflow reduction, with S1 configured on the board, on your air handler control board, the BO output or the OB input, it becomes a heating call. So this is important. So with this switch in the heat pump position, when I get 24 volts on the OB terminal from the thermostat, it automatically knows when we configure the board, it automatically knows it's a heating call. It's a heating call. Now, the reason I'm stressing this is this, because on a normal heat pump, when I say normal, our normal heat pump, we energize O for cooling. But on the HMH7 product here that we're talking about today, we energize B for heating. So it's important that we know that this switch, number one, has to be in the heat pump position to tell the air handler, hey, I'm on a heat pump. And then it has to be set up with the S1 configured on the board so that it recognizes that OB input is a heating call. By the way, all this is explained very, very well in the setup. I believe it's page number 13, if memory serves me, in the install guide as well. Another little excerpt from the install guide that we have to keep in perspective is that AC switch configures the control board to operate correctly with an air conditioner if it's in the AC mode in the on position, or a heat pump if it's in the off position. Now this is important. So when you guys get these air handlers, you look at that dip switch. I think we ship them for air conditioning, AC. So one of the absolute most important things is when you get this variable speed air handler on, and you're going to put it on a heat pump, you're going to have to select that HP, that little HP switch, so the air handler knows it's on a heat pump. Now this is equally important because down there in Florida, you might take one of these variable speed air handlers and put it on you may put it on a straight cooling product with just a heat strip. That's all well and fine. Just make sure that switch is in the AC position if it's an air conditioner. Any questions or comments up to this point before we continue? Everybody good?
I think so.
Okay. All right, now with the switch in the on position, in the AC position, the control will treat any Y call as a cooling call. That makes perfect sense. So if that switch is in the on position or the AC position, it's going to see any Y call as a cooling call. But now if the switch is in the off position, A Y call is going to be treated as a heat pump heating call unless you accompany it by that OB signal for reversing valve cooling operation on a normal heat pump. So the point is that the normal operation, when that switch is in the off position, a Y call all by itself on the heat pump will mean what? It'll mean give me heating. Unless you have that OB for cooling reversing valve operation on a regular heat pump. Because remember, on our normal heat pumps, not the HMH7 like we're talking about today, but on our normal heat pumps, you energize the OB terminal for cooling mode of operation when you switch that reversing valve. Now, this is really important. If the control is set up for the S1 input, which is something you're going to do on the control board, you're going to set it up for S1 input on the HMH7 product that we're talking about today. If the control is set up for an S1 input, the Y call, along with an OB call, becomes a heating call. Because remember, on the HMH7, that B input or that OB input on the HMH7 with the S1 programmed onto this board becomes a heating call. I know it seems a little bit confusing until you start really getting in, and it makes perfect sense, because basically we've got to tell the board two things. Number one, I'm on a heat pump or air conditioner. Number two, am I going to utilize the S1 circuit with an HMH7? And if the answer is yes, then that OB signal becomes a heating call from the HMH7. But if you don't set up the S1 input, if you do not set up the S1 input, and by the way, while I'm on this line of thinking, the only product that we have in our entire residential inventory that has an S1 circuit is the HMH7. So this is why I'm stressing this. So if you set this air handler up with an S1 input, then that OB 24 volts from the thermostat becomes a heating call. But on a regular heat pump, it's a cooling call. Does that make sense to everybody? Questions or comments?
I think we're tracking it, but it is a lot.
It's a lot to know, and again, this is one of the reasons we're making this recording, so you can go through and talk about it, and I would recommend that, take the install guide and be thoroughly familiar with it. Like I said, I think it's page 13 talks about, all the steps of going through. It's not a whole lot. You just kind of poke a button and yes, you want S1. I mean, just follow it, and it works very well. But so this has been. Go ahead.
Sorry to interrupt, but can we provide this presentation in PDF to them, the wiring schematics and so forth? Would that be helpful?
I think we could probably do that. I've got some, we could do some block, Tony, I'll get them to you. We've got some block wiring diagrams that we can do with this. And then, yeah, they could utilize this as a PDF. And then, of course, like you said, the install guide, and
yeah,
and together, hand in hand, it'll make perfect sense. Good.
Sure.
That's a good idea.
Okay.
You bet.
Right after the storm down here, one of our customers on USEPA owned an AC company up north, and they were a York dealer. So I have put one of these in, and I remember working through the book and doing the S1 and having an issue where sometimes in yellow it was sometimes calling for cooler would heat, but we worked our way through it and we got it working well. And that
absolutely,
that system's been up and running for like 18 months, no issues, and they love it. So I have experience with one of them, but it was a York.
Okay, good. Thank you for that good input. I appreciate that. So fellas, at this time, let's go ahead and walk through the low voltage wiring, literally wire for wire, from the thermostat to the indoor unit to the outdoor unit. And so from the thermostat, we're going to take that OB terminal, and that's going to energize the reversing valve in the heating mode of operation on our product, on the HMH7 specifically. So that'll go all the way through, basically OB to B outside. Let's say we have a two-stage heat strip. I'm just showing a two-stage heat strip on the air handler. If you do have a two-stage heat strip, which you probably won't down in your part of the country, but if you do, W2 is your second stage auxiliary heat call. W2 from the thermostat to W2 on the air handler. Now, W1 is going to go all the way through. It's going to go W1 from the thermostat to the air handler to the outdoor unit. And the reason we do that, we have that W to the outdoor unit because when we go into defrost, remember when you take a heat pump and you put it in defrost, it goes into the cooling mode. So we're going to generate a W call for auxiliary heat from the outdoor unit during defrost. That way we don't freeze the homeowner out when we go into defrost. So that W1 is going to go from the thermostat to the indoor unit to the outdoor unit. Now watch this. Y1 from the outdoor unit, or from the Y1 from the thermostat is going to go to Y/Y2, and then all the way outside to the outdoor unit on a Y call. Now, guys, this is really, really, really important. The default airflow on the HMH7 when you get a Y call, the default airflow is going to be Y/Y2 on the air handler, which is second stage airflow or full cooling airflow. So it's important we go from Y1 on the thermostat to Y/Y2 on the air handler to Y outside. Because what's going to happen when we have this board set up for S1 input, when it sees an S1 signal, it's going to automatically go to reduced airflow to 65%. But the default airflow, whenever I get a Y call, we're going to go ahead and have 100% airflow on the indoor unit. And then if the outdoor unit generates an S1 signal, then we'll reduce the airflow. So I want to make sure everybody understands that. Y1 from the thermostat to Y/Y2 terminal, or your Y/Y2 wire on the air handler, to Y2 or to Y outside for our default airflow of 100% unless the outdoor unit generates that S1 signal. Everything else is pretty straightforward, fellas. C is 24-volt common. We want to make sure and select a thermostat that is not power stealing. We want to make sure we have just a conventional thermostat that's got common wire going all the way through from the thermostat to the indoor unit to the outdoor unit. R is 24-volt hot. Now watch this. Unlike most heat pumps out there in the world, we do not take our terminal outside. We don't take that outside. It strictly goes from the thermostat to the indoor unit because the control system outside is just looking for a 24-volt input. It doesn't require 24 volts to operate the reversing valve and all that. It has its own power source out there. So we do not take our terminal outside. So 24-volt hot goes from the thermostat to the indoor unit, and that's it. We don't take that outside. G terminal, you'd expect this. That's your fan call. That's going to be pretty standard and straightforward in the industry. Your G call is going to be your fan call. And then now watch on the heat pump. We're now going to have an S1 goes to S1 on the control board on the JHVT air handler. So this is really, really important. You guys catch this. We're not even going to hook up the Y1 terminal. Let me say that again. We're not going to hook up the Y1 terminal because if S1 is configured on the control board as an input from the outdoor unit, you do not utilize Y1 because now we've set it up to know it's on an HMH7. We've set the board up to know it's looking for an S1 signal. It knows it's on a heat pump. It knows it's on a HMH7. And now in the outdoor unit it says, hey, I want reduced capacity on the airflow. It'll generate an S1 signal. And when the indoor air handler sees that S1 signal configured like we've talked about, it'll automatically know, oh, I'm going to reduce my airflow to 65%. So this is your basic block wiring diagram, wire for wire. We're going to go ahead and do some little animations here in a minute or two. And that animation will kind of show you what's going to happen when the outdoor unit generates a S1 signal. But before we do that, is there any questions or comments on this block wiring that we've talked about? Is everybody good?
Yeah, I think we're good. Okay.
So let's go ahead and talk a little bit about, now watch the animation. So let's say we're cruising along at 67% capacity. I'm just making that up. And it's starting to cool the house down, and it's looking at the suction line temperature. It's looking at liquid line temperature. It's in the evening time. The sun's going down. It's starting to cool off a little bit. and the unit hits about 65% capacity. At that point, what's going to happen is the outdoor unit's going to generate an S1 signal. Watch that animation again. It's going to generate an S1 signal. And when it generates that S1 signal, it's going to command the indoor unit to reduced airflow. Now, guys, remember, this outdoor unit modulates from 35 to 100% capacity. However, we're going to have two different airflow settings on inside. So basically, our airflow inside is going to be 65% on that first stage airflow and 100% airflow for 100%. So S1, when we configure the board to look for S1, like we talked about earlier, when it sees S1, it automatically knows, hey, I need reduced airflow, and that air handler is going to automatically go back when it sees that S1 signal. It's going to go back to 65% of whatever you have programmed on the board with your dip switches for your cooling airflow. So if I set up my cooling airflow for 800 CFM on a 200, on a 2-ton unit, a 65% of 800, whatever that would be, what would that be? About 450 CFM, something like that. It's going to go ahead and it'll bring that back, or 500 CFM, whatever that is. It'll bring that back to that reduced airflow to better match the capacity of the outdoor unit with the airflow inside for a lot higher level of comfort. That's what this is all about. The reason we're commanding low airflow or reduced airflow is when the outdoor unit reaches a capacity of around 60 to 65%, it's going to generate that S1 signal. Now we're going to reduce the airflow inside for better comfort and humidity control. Any questions or comments on how that circuitry is working in the block diagram that we've talked about?
So when the condenser still has the ability to run down to that 30 or 40%, and the air handler would stick to 65 being its lowest?
I love that. Good question. That is absolutely correct. So 65% airflow is a bit of a compromise to your good point. I guess that's where you're headed with that, because you're right. When we get down to 42% capacity, we're still blowing 65% airflow. But this is a great advantage over blowing 100% airflow at 40% capacity. So that's kind of the compromise of the HMH7. It's a great product, but it's super simple. And to make part of that simple package, so to speak, we had to choose an airflow. We had to choose two fixed airflows for basically a modulating unit outside, 35 to 100% modulating unit outside. What are we going to pick for airflow? And so 100% airflow for 100% capacity, and then 65% airflow would be our airflow for anything under about 60% capacity of the unit. Good question, but you are correct. Two airflows inside, 35 to 100% capacity outside. Great observation. Any other good questions or comments?
I don't think so.
Okay, good. So I want to talk a little bit about utilizing as an alternate what we call the HMH7 AK002 relay kit. Now, this relay kit is going to be used on any of our other variable speed products. However, I wanted to go ahead and talk a little bit about this because in some areas of the country, we've actually discovered in some areas of the country, due to local power quality issues, in other words, they're getting a lot of voltage surges and stuff like that, that may clear the air handler control board of that S1 input. Now, we haven't had any results of it burning anything up or anything like that, but we actually had Tony, actually up in your neck of the woods, we had a really good contractor up there that he's just had some power quality issues. And he called and asked me one day, he said, listen, I'm losing the function. I get a little voltage spike, and I've tried surge protectors and stuff like that, and they seem to help. But up here, where I'm at, he said, we've got some kind of lousy power sometimes, and my board is losing the S1 function. Can I use the 002 relay kit and just set it up as a regular air handler, without the S1 input, and utilize the relay kit like I would on any other variable speed product that you've got? And I said, well, sure you can. So we're going to go ahead and talk a little bit about that as well, because if you guys get into a situation where, and it probably may or may not happen, but this is just for your own education here, that if you get into a situation where you have some power quality issues and you're losing that S1 input on the board for whatever reason, then you can use this relay kit as an alternate and just set up the air handler as just a regular variable speed air handler without the S1 input, and then utilize the relay kit to switch your airflow. So we're going to go ahead and talk a little bit about that as well, because it's important that we know that there is an alternate use of this relay kit, even on the JHVT air handler, if you're having some power quality issues. This will give you a more reliable system, or potentially a more reliable system, if you utilize this relay. So let's go ahead and talk a little bit about that. So basically what the S1, instead of taking S1 directly to the board, what we're going to do is we have a relay kit, the 00 relay kit. It's basically 2 relays that are mounted on a board. Everything that we talked about earlier as far as B terminal, that's going to stay the same. You know, you're going to take B, you're going to go out to B on the outdoor unit. W2 is going to stay W2. W1 is going to go all the way through, just like we did before. Fellas, it's the same wiring that we did before. It's just that we're going to be utilizing some relays instead of the S1 input on the board as an alternate if you need to. Y is going to go outside just like it did before. C is going to be 24 volt common, just like you had before. None of that changes. 24 volts on the hot goes inside. It doesn't go outside, just like before. And G is your fan call. So all that wire is exactly the same. But if you utilize the 002 relay kit, you're going to notice that relay kit's going to have 2 relays on there. One's going to be called an S1 relay, and the other one's going to be called the RV relay, for reversing valve relay. So again, you're going to set your board up for your airflow. You're going to set your switch to heat pump, just like we did before. All that stays the same. The only thing is you're not going to program with this alternate method. You're not going to program the S1 input on the control board itself. Instead, you're going to be doing these relays as an alternate. So if you utilize this relay kit as an alternate, what you're going to do, you're going to take one side of both relay coils and you're going to go up to common. That makes sense because they're 24 volt coils on those relays. And then what you're going to do is you're going to take the B terminal, or more specifically, the other side of the relay coil on the S1 relay. You're going to take that up to S1. So basically now when we get an S1 signal, it's going to operate a relay instead of going directly to the board, like we did in the previous slides. Then you're going to take 24 volt common, or not common, you're going to take 24 volts from Y terminal. So whenever the thermostat says, hey, give me Y, it's going to energize the common terminal of that S1 relay. You're then going to take the normally closed contact on that relay, the S1 relay, and you're going to take it to Y/Y2. You're then going to take the normally open contact on the S1 relay and take it to Y1. So you can see that basically what we're doing, we're allowing S1 relay to switch our airflow for us. The normally closed contact, again, it'll be the default airflow. The normally closed contact, whenever I get a Y signal, I'm going to drive the air handler to full speed airflow, Y/Y2, high cooling airflow. And then if I switch that relay, which we'll animate for you here in a little bit, it'll then command low airflow on Y1. So we're not even utilizing the S1 circuit on the control board itself. We're letting the relay do our airflow switching for us with the S1 relay. Any questions or comments on that simple block wiring diagram? Because we'll animate everything and kind of show you how this works in a minute or two. But just wanted to put this out right now with any questions or comments.
I don't think so.
Everybody good? Okay. The other relay, the RV relay, the other side of the relay coil, remember one side went to 24 volt common. The other side of the relay coil on the RV relay goes up and grabs B terminal. So basically, anytime we energize B, we're going to energize that relay or move that relay. We're going to have 24 volts from Y terminal going to the common terminal on the RV relay, just like we had on the other relay. But now watch this. The normally closed contact on the RV relay is going to go up to the BO terminal. Now, this is very, very important we catch why they're doing this, because if we don't set the control board up for S1 input, if we do not set the control board up for S1 input, and we have it in the HP, the little switch for HP for heat pump, automatically the control board at that point is going to be looking for an O signal in the cooling mode. So the default function on the control board, if we don't have an S1 input control or programmed on there, the normal everyday function of this air handler is that in the cooling mode, it's going to be looking for an O signal for advanced operation and advanced cooling features, like dehumidification features and stuff like that. So the only thing this RV relay is doing is that in the cooling mode of operation, in other words, we don't have a B signal, we don't have a B for heating. In the cooling mode of operation, this air handler has to see that O signal or that OB signal in the cooling mode. Now watch the animation, everybody, real quick. So basically, we've got this wired up with the relay pack as an alternate. So when I energize S1 outside with this alternate relay circuitry, let me back up the animation again, watch the relay. When I energize S1 outside, bang, it switches that S1 relay and commands low airflow. That's all that relay does on S1 relay, is it switches from default of high airflow, normally closed contact. When I generate an S1 signal, bang, it switches that relay and it gives me low airflow. That's all that relay does, is to reduce or to give me a low airflow command when the outdoor unit says, hey, I've got S1, give me low airflow when I energize S1. Any questions or comments on that?
No, makes sense.
Okay. Now, on the RV relay, the only thing the RV relay does is when we go to the heating mode of operation, bang, when we energize B for heating outside, watch that relay again. We energize B for heating outside, we switch that relay, and we break that OB signal to the air handler. So now the air handler knows that, hey, I'm in the heating mode of operation. I don't see the O signal anymore. Let me back up. I don't see the O signal anymore. So bang, I'm going to go ahead and energize that relay and break that O signal for the air handler. So now it knows it's in the heating mode. So the relay function, again, this is exactly how you'd wire up if you had a furnace, a variable speed furnace. This is exactly, you'd use this relay kit. If you had an older AVC air handler, you'd still use this relay kit. So this whole relay function has been around for a couple of years now on our variable speed indoor products, other than the JHVT air handler that we're talking about today. But the question came again, we got a really good contractor up north. He said, man, I've been having some issues. Can I take the JHVT air handler, treat it like just a plain old regular variable speed air handler before you had that S1 ability on the control board to program, and can I still use the relay kit for reliability in some of those areas of his part of the country? And I said, absolutely. So I just wanted to share this with everybody, that if you're having some voltage surges and you're having some power quality issues, and the control board is losing its S1 ability, or for whatever reason, you can still utilize the relay kit if you want to as an alternate. Any questions or comments on that before we continue?
I have a question for Chad.
Go ahead.
No, usually with the AL19s and 21s, we don't really have any issues.
Okay, was there a question on the AL21 or?
John just asked me if I use any of these relay kits now, and I told him we haven't had the need for it yet. On the AL19,
okay.
AL21s, we don't have any issues.
Okay, good. All right, well, fantastic. Like I said, fellas, I just wanted to, just from an educational standpoint, I just wanted to let everybody know that if you get in a situation where you have an area or a subdivision having some power quality issues, some little voltage spikes or whatever, and the control board doesn't recognize the S1 signal or whatever, you can always utilize the relay kit as an alternate as well. Let's talk a little bit about airflow real quick. Was there another question?
Yeah, so let's say we get out there and it has one of these relay kits and it's not working. Is there any way that we can wire around it to keep the people cold for the night until we get a new kit?
So if you've got the relay, if basically the worst case scenario, let's say the relay coil burned out, and we're just, oh gee whiz, the relay coil is the relay's stuck in the normally closed position. Worst that's going to happen is you'll just have 100% airflow. Everything else will still work. If those relays, for whatever reason, the relays are burned out and they're in their normally closed position here, which would be right there. That's default right there. The relays are unenergized. The contacts are stuck. The coils are burned up. The worst that happens right now is that you're just stuck with high airflow.
Okay.
That's it. And so yeah, so that's a great question. I mean, so you're stuck with high airflow and you're stuck in the cooling mode right now, basically. And so that would be your worst case scenario. Good. That was a great question. Fellas, let's talk a little bit about some airflow considerations. Now, one of the things we want to remember on every install, we want to make sure that we confirm proper airflow. The HMH7, because it is a modulating unit, airflow is actually more critical than it is on a regular unit, because remember, it's looking at suction line temperature. It's looking at, in other words, it's looking at the temperature of the evaporator coil by looking at the suction line temperature and the suction line pressure. And so we want to make sure that we've got proper airflow across that indoor coil, as well as a good clean coil. And we want to make sure that, we've got proper airflow, because if we don't, what's going to happen, the outdoor unit's going to see a colder evaporator than it normally would if you had lousy airflow inside. So the normal thing that it's going to do is going to say, oh, it's cooling off in the house, therefore I'm going to have to start reducing my capacity. So please remember, your capacity reduction is going to be looking at outdoor air temperature and suction line temperature and liquid line temperature and all these different refrigeration temperatures and pressures. But it's important that we have proper airflow, because if we don't have proper airflow, the unit's going to start reducing its capacity because it thinks it's cooling the house off inside, right? So please remember that airflow is very, very important, especially on a modulating unit, because of what I've just articulated. In addition, when you're building your duct system, this is right out of Manual D. We want to make sure, and I'm not going to sit here and go over every single one, but you can kind of see the highlight here on your main trunks. It's recommended Manual D. This is right out of Manual D, which is Airflow and Duct Design, Residential Airflow and Duct Design tables. Just keep your velocities under control as you take a look at these different target velocities. By all means, keep this in perspective, because we don't want to have the air moving too fast across those coils, because if we do, they're not going to have proper heat exchange. So 700 feet a minute on the supply is your main trunk supply velocity. Branch ducts should be around 600. Registers, grills, and diffusers need to be at 500 is recommended on the supply, and 400 on return. And this is a big one, especially down in Florida. I know you guys put a lot of air handlers and stuff in closets. If you have a filter grill, if you got a filter grill, in the closet door or whatever, your return air filter, if you've got a return air filter grill, make sure you do not exceed 300 feet a minute velocity across that filter. This is Manual D recommendation. So again, when you're building your duct system, give me 400 CFM per ton, and then dial in some of these velocities as well, and you'll have a good, reliable duct system and good operation. So with that, let me go ahead and thank everybody for watching the program with me. But don't go away yet. Let me go ahead and get rid of the PowerPoint, and I'm going to open up get my camera back on so that Tony and I can answer any questions for you and whatnot. So let's do that. Let's go ahead and open the floor up, and if there's any questions or comments.
Yeah, Chad might have a couple. He stepped out to take a photo. phone call. Let me see if I can recognize.
I didn't hear the last comment, Tony. Were we waiting?
He's thinking that Chad may have a couple of questions, but he had to step out for just a moment. So John's rounding him up. So we'll just take a couple minutes here and pause.
Okay. And Tony, I'll get a series of block wiring diagrams to you this morning sometime. I'll get that.
Thank you.
And that'll be a PDF file. It'll be basically what we've talked about, but it'll just be block wiring diagrams of what we talked about.
They're very cool looking. What do you say? No, sorry about that. I got a piece of equipment delivered. So is there, if we are replacing a half ton and the half ton seems to be what we need for the house, is it going to be recommended that we go up a half ton and then just set the airflow for 2.5 or 3.5?
That's a good question. So let's say, for instance, you've got your load is 1.5 ton, and the only product that you've got close is going to be your HMH7, right?
Yep.
And so, which is going to be a 2-ton model. So what you're going to do, you're going to go ahead and set your airflow up like you normally would. In other words, set your airflow up for 800 CFM for the outdoor unit on a 2-ton unit. And then remember what's going to happen, the outdoor unit's going to modulate back. And so if you really only have most of the time, like a 1.5 ton load, for instance, it's going to modulate back to that 1.5 tons of capacity. And when it hits about 60% or 65% capacity, it's going to go ahead and reduce the airflow inside anyway. So if you take 65% of a 2-ton unit, you're down to what? Whatever 65% is, which is going to be less than 1.5 tons. So the point is you're going to go ahead and set your airflow up like you normally would based on the outdoor unit. And then when the outdoor unit hits that point of capacity where it's going to say, okay, I'm down to 60% or 65%, we're going to go ahead and reduce the airflow at that point on the indoor unit anyway. So you should be fine. And then on those really, really hot days, if it's beyond 95 or whatever you designed for down there on a 100-degree day or 105-degree day or whatever the case may be, now the unit's going to have some capacity to keep the house comfortable on those days that are outside of the design as well. And that's the real beauty of the HMH7 with that modulating capacity. I mean, like I said, the 2-ton unit's going to screw down to about 1.25 tons or so, and it'll go on up to 100%. And then, so that's where the real comfort comes in on that thing. Tony, you've got one in your house. Tell the team a little bit about the HMH7 you've got in your own house.
Yeah, thanks, Joel. Yeah, I've had the 3-ton model. It has been in for 2 full heating and cooling seasons, and what I notice about it is just the comfort that it delivers, particularly with humidity removal in the summertime, and you can really set the thermostat at a higher setting because it takes out the humidity. And the other thing that I notice about it is its quiet operation. You literally cannot hear it run. So for those, clients that have maybe they've got a Florida room out back or something like that where their air conditioning unit's sitting close to it, then, one of the things you can emphasize is how quiet it is. It operates at 52 decibels. Versus our premium models. And Joel, Chad's company has from early on, they've installed a lot of our Momentum series. And
Oh,
so
good. Okay.
those units are quiet because they have a sound blanket and all that, and they are so large they move less air and stuff, you know, and with a big cabinet and coil surface. But they still operate in the 70 to 72 decibel range versus 52. And so 52, as you can relate to your homeowners, it's about like a
domestic
refrigerator or dishwasher. You just can't hear them run. And
good point.
so yeah, I can't say enough good things about this, and we're very excited. This unit will be discontinued as we go forward into the new R454B models that are going to be introduced later this year. And it's going to be replaced with what's called an HH8. So it'll be nominally a 17 to 18 SEER unit, fully modulating. The cabinetry will look a little bit different. In fact, it's really cool cabinetry with a really nice shaped condenser fan guard and all that. And the thing about these units, they will all qualify, is my understanding, for the federal tax credit. It's called 25C.
Yep.
And what that means is for homeowners, if they buy one of these heat pump systems that qualifies, has to meet certain efficiency requirements, it'll qualify for a $2,000 federal tax credit. So a lot of times, that's something that you can make your customers aware of that other companies won't. We do have on Navigator, now that you guys have full access to it, if you put in the search bar, and that's one of the best ways to access information, because Navigator is everything from marketing to product to programs to big chillers and parts, and so you can imagine all the stuff that's there. But if you put in the search bar 25C tax credit, and then you'll see what all documents are associated with that, and you'll need to go to documents. And my point is, there's some consumer-facing materials that you can use with your customers. You know, we're HVAC guys and gals. We're not tax people or accountants or anything, but it's really our role to explain that to consumers. Hey, here's a piece of information on this, and by the way, this unit's not only quiet, delivers great comfort, but now you can get a federal tax credit on it. Now, that's not with these units that you saw today. There's one model that qualifies for the tax credit on these models, and that's the size 34. So it's kind of nominally kind of between a 2.5 and a 3 ton. But the new units will all qualify. Not to get off on a tangent here, but the reason that these super efficient, super quiet units don't qualify is because of the way AHRI set up, the way the testing is set up.
The way they test them,
by the AHRI standards as it relates to modulating equipment. And Joel could probably shed more light on that than me, but it has taken us a while to get the units developed that will qualify for that tax credit, though. So yeah.
And that's a good explanation. Basically, it's how they test it is what that is. But good, excellent comments. Any other good questions or comments before we secure for the morning? Everybody good?
I think so.
Well, fellas, let me go ahead, think on that for just another second or two. I'm going to go ahead and stop the recording at this time. And again, what we'll be doing, fellas, is we're going to be posting